Hey, welcome back. This is 0965, section 7.3, adding and subtracting rational expressions with the same denominator. So we're continuing on basically with this idea of working with fractions, but now with variables. We'll begin with addition. Recall how this works with in arithmetic with fractions. So maybe you had something like 4/5 plus 6/5. So what you would do is just carry over the common denominator. That doesn't change, but then you add the numerators over that common denominator. Okay? So 4 plus 6 is 10 over 5. And then we could reduce that using whatever method you're used to. 5, 2 over 1, which is 2. Okay. So we want to recreate the same process but with variables, so let's sort of just dive right in and start looking at problems, okay? Problem 4, we have 9x all over 24 plus x all over 24. Okay, so literally you just borrow that common denominator, so that part's done for us. In the next section, we'll learn how to do this without common denominators, so we have to make the common denominator first. And then the numerator, you're just adding these two things together, 9x plus x. You can do that in your head. It's just 10x, 4. And then you could simplify accordingly. If you factor 5 times 2 times x, 24 is like 2 times 12. So we can remove a 2 at least, and then we have 5x over 12. Okay, so it's pretty simple at first. They'll try to make it more and more complicated as you go along. Here's number 12, 8 over x plus 6 plus 10 all over x plus 6. So this time the common denominator is a binomial, okay? X plus 6. And the numerator then just go 8 plus 10. And certainly that's just 18. Okay, now there's nothing else you can reduce. There's no common factor in the denominator and the numerator, so you're done. Let's get 18. So we have y squared minus 2y all over y squared plus 3y, and then plus y squared plus y all over y squared plus 3y. Okay. Same denominator, so you just borrow that, y squared plus 3y. And then the numerator, you're adding the two numerators together. So you had y minus 2y plus y squared plus y. Okay. 1y squared, 2y squares. And then negative 2y plus y is just minus y. Y squared plus 3y. And then you look to see if you can simplify anything. And sure, there's a GCF in the numerator of y. And the denominator, there's also a GCF of y. And then we have a common factor of y in the top and bottom. And we're left with 2y minus 1 all over y plus 3. Okay? Okay, great stuff. What's harder is the subtraction. So note, these have all been addition problems. And I mean, as long as you keep your senses about you, you're fine. The only big difference is distribution. You have to make sure you kind of distribute the negative to the entire second numerator. Okay, so distribute the negative. It's kind of the key point. Distribute the negative. Okay, so let's dive right in. Here we have 28. 2y plus 1 all over 3y minus 7, and then minus y plus 8 all over the 3y minus 7. Okay, so I'm going to subtract the numerators. So you have 2y plus 1 minus, but you can't just subtract part of the numerator. So to indicate by subtracting the entire numerator, you have to put it in parentheses, like that. It's all over the common denominator. And then distribute that negative. Okay? So you'll end up with 2y plus 1, and then minus y, and then minus 8. And then combine like terms. 2y minus y is y. 1 minus 8 is minus 7. and then we're kind of done. There's no more common factors in the top and bottom. Okay, so let's get the next guy. X cubed minus 1, whoops, x cubed minus 3, all over 2x to the 4th, then minus 7x cubed minus 3 all over 2x to the 4th. Okay, common denominator of 2x to the 4th. Then the numerator again, x cubed minus 3. I'm subtracting the entire other numerator, so not just part of it, the entire thing. 7x cubed minus 3. So you got to put it in those parentheses. Then you can distribute the negative. So I end up with negative 7x cubed. And then negative times a negative 3 will give you plus. That will flip the sign to plus 3. So fourth. Combine like terms, so negative 3 plus 3 is 0. X cubed minus 7x cubed is minus 6x cubed. So over 2x to the 4th. And then we could reduce that. Negative 6 halves is the same as negative 3 over 1. So, you literally divide top and bottom by 2. But negative 6 halves is the same as negative 3 over 1. And then this x cubed over x to the 4th, you can use your exponent rules. If you remember, you have a to the x over a to the y. That's equivalent to saying 1 all over a to the y minus x. So you can subtract exponents that way. You could also write it a to the x over a to the y equals a to the x minus y. Right? We'll move the x cubed down, and you'll get x to the 4 minus 3, which is the same as x to the 1. Okay? And we don't need the right x to the 1, we just write x. If you don't like that explanation, you could always think of it as negative 3 times x times x times x. So it gets a bit silly after a while. All over x times x times x times x. And then you're removing the 3 of the x's, because those are common to the top and bottom. You're just left with the 1x in the bottom. Okay? Okay, the next question is the video quiz. Officially, the video quiz, video quiz, video quiz, video quiz. 2y squared plus 6y plus 8 all over y squared minus 16 minus y squared minus 3y minus 12 all over y squared minus 16. Okay. Common denominator, or y squared minus 16. And then we're subtracting the numerators over the common denominator. So 2y squared plus 6y plus 8 minus, and again, it's the entire numerator on the second term, y squared minus 3y minus 12. Okay. Again, distribute the negatives, so get 2y squared plus 6y plus 8 minus y squared plus 3y plus 12. That's all over y squared minus 16. 2y squared minus y squared is y squared. 6 plus 3 is 9y. 8 plus 12 is 20. All over the y squared minus 16. And we're hopeful always for simplifications, right? And I think we might be able to get something to cancel out here. We can factor the numerator into y plus 4, y plus 5. And the denominator is a difference of squares. That would be y minus 4, y plus 4. And certainly there's a common factor of y plus 4 in the top and bottom. And you're just ending up with y plus 5 over y minus 4. Okay, so that was our video quiz for the day. Okay, there's one small detail here, and I think it's kind of confusing, to say the least. Hopefully we'll be able to stomach it. Section 3, opposite denominators. And again, what they mean by opposite is that they're additive opposites. So if you were to add them together, you would get 0. So let's take a look at this guy. 6 over x minus 5 plus 2 all over 5 minus x. I think what they kind of want you to do in the book is to multiply the second term top and bottom by a negative, -1. Okay, so that's one way to kind of look at this. The shortcut kind of trick, quote unquote trick, we don't like to think of tricks. Math is not about magic. The shortcut way is to do it like this. You go x minus 5, change the sign of the next term, and then just rewrite the denominator so it looks like this. Okay, so that's one way to think of it. And then you subtract the numerators over the common denominator. So 4 over x minus 5. Okay, I think the way the book handles it is kind of like multiply top and bottom of that second term by -1. Okay, so if you multiply top and bottom by -1, you kind of get the same effect, right? So you have 6 over x minus 5 plus -2 all over, so instead of 5 minus x, you're distributing this negative here. You get -5 plus x, -5 plus x, which is basically just x minus 5 if you were to rewrite it, right? So you get 6 over x minus 5 plus -2 over x minus 5. So you'll see that kind of thing done in the book when you read your book. And this final expression here is exactly the same as this expression right here, right? It's just, reminding ourselves from basic arithmetic up here at the top right. If you have 3 minus 2, that's equivalent to 3 plus -2, which is kind of what we got going on here. One other thing with fractions, I just want to note before, there's so much to tell you, right? If you have something like -2/3, you can put the negative in the numerator, you can put the negative also in the denominator. But when you're dealing with binomials, so if you had something like, and I'll get back to this problem here in a second, but if you had something like negative and then x minus 3 all over x plus 2 like this, when you move the negative up to the numerator, you have to kind of include the entire numerator with the negative, like that. Okay? And then you would have to distribute that negative. If you bring it downstairs, if you bring that negative to the denominator, again, you kind of have to include the entire denominator. Okay? So this is kind of our variable version of the property of negatives with fractions. Right? So those were kind of like the same spiel. So I just wanted to note that. Okay, so anyways, sort of using the book method, multiplying top and bottom by a negative, we end up with the same kind of format, just with the negative in the numerator. And then you could add the two numerators, 6 plus -2, all over x minus 5, and that will be just 4 over x minus 5. Which is exactly what we got, doing the kind of the change the sign and then change the order of the denominator. Okay, so let's look at some more examples of this, and then we'll go to my math lab. 42 here, 6x plus 5 all over x minus 2 plus 4x all over 2 minus x. Okay, so kind of the shortcut, 6x plus 5 over x minus 2, change the sign in between the two fractions, and then that will reverse the order in the denominator. So it's 2, and then we could subtract the numerators over that common denominator. So 6x minus 4x is 2x minus 5 all over x minus 2, and then that's as good as you can get it. Right. Okay, let's try another one. Here's 54, and we have y all over y minus 4 all over 4 minus y. Okay, so again, it's just change the sign between the two fractions and change the order of the denominator. Okay. Or just reverse the signs of all the terms in the denominator. So if you have 4 minus y, just make it y minus 4. Okay. Then we're adding the numerators over the common denominator, and those are not like terms, so we'll leave it alone. Okay, let's do one more. So 64. I have 2x plus 3 all over x squared minus x minus 30 plus x minus 2 all over 30 plus x minus x squared. Okay, so again, you know, 2x plus 3 all over x squared minus x minus 30. Change the sign between them, x minus 2 all over, and then reverse the signs of everything in the denominator. So you will end up with positive x squared instead of negative x squared, negative x instead of positive x, and then negative 30 instead of positive 30. And then you're subtracting the numerator, so you subtract the entire second numerator, so you need those parentheses. And then we could subtract, so 2x plus 3 minus x, don't forget to distribute. And then we're getting 2x minus x is just x, and then plus 5, and maybe we can even do a simplification here, right? So factoring the denominator, x and x plus and minus. It looks like the bigger number that has to be negatives, right? So 6 and 5. And then, yeah, okay. So we can finally write our answer as 1 over x minus 6. Okay. Okay. Let's go ahead and take a look at my math lab, see what kind of ridiculousness they have set up for us. 90% of the problem is just silly mistakes. You'll make one little error, you know, and it'll screw up the problem. So sometimes it could be pretty frustrating, especially if you have a long problem like this. Anyways, b squared minus 7b all over 4b squared minus 16b plus 7 plus b squared minus 4b all over 4b squared minus 16b plus 7 minus 3b minus 2b squared all over 4b squared minus 16b plus 7. Just take a moment to make sure you copied it correctly. Okay, so I think it's copied correctly. All right. I'm going to combine all three of these numerators over the common denominator, believe it or not. So the first two I'm adding together. If you want to do two at a time, so if you just want to do these two first and then subtract that third one, that's fine, you can do that. But it's okay to do it this way as well. So anyways, b squared minus 4b. And finally minus, but you do have to remind yourself, all right, I have to distribute the negative. Okay. So it's all over 4b squared minus 16b. 7, my b's look just like 6's. So here we go. I got b squared minus 7b plus b squared minus 4b. Distributing the negative, minus 3b plus 2b squared all over our common denominator. B squared minus b squared is 0. Oh, whoops, those are added, sorry. So 1, 2, and then 3, 4 b squares. And then 7 minus 4 is 11, minus 3 is minus 14b all over our common denominator. Maybe we can factor this, I don't know. 2b times, so we have 2b minus 7. Yeah, that looks pretty hopeful. Down here, probably a 2b minus 7, and then you're going to have to go minus 1, and then another 2b. Does that work? 14, and then 2. Yeah, that works. So we can remove those. We get 2b all over 2b minus 1. Let's go make sure that's correct. Fraction bar up, 2b all over 2b. Okay, so you got to do some order of operations with this one then. So 4y over y minus 5 minus 6 over y minus 5 plus 3y minus 6 over y minus 5. So to do the parentheses, whoops, I didn't want, well, sure, I got the answer there already. So we'll see if we get it. Right, so I'm going to do the parentheses first. So, you know, PEMDAS, please excuse my dear Aunt Sally. Right, so parentheses first. So 5y over y minus 5 minus. So I'm adding these numerators, 6 plus 3y minus 6 over this common denominator of y minus 5. 4y over y minus 5. Simplifying this, 6 minus 6, 0. So you just get a 3y up top. I can drop the parentheses. And then subtract the numerators of the common denominator. So 4y minus 3y is just 1y over y minus 5. And that's what I should have got from the answer. Y over y minus 5, yeah. Okay, next. So here we go. Some malarkey. Subtracting these two fractions. And it's like I'm cheating, I have the answer there. But believe me, it's better if I have the answer than make a mistake. And just for the sake of sanity. It's nothing worse than when your professor's up there making mistake after mistake after mistake. It's just poor planning on their part. Anyways. And I do make mistakes. I'll be tired and I'll be going through problems, and you make mistakes, it just happens. There's nothing you can do about it usually. You try to avoid it, especially if you're doing something important. You know, I want to make sure I get a full 8 hours of sleep. Anyways, we have a common denominator here, right? All right, so it's just 4x minus 4y all over this ax plus bx minus ay. Not hard, but the idea is you probably simplify it, right? They're not gonna. Okay, so the numerator I can factor out 4. So I'm factoring the top and bottom. And the bottom, it looks like it's a grouping, right? So I can factor out an x from the first two, and I can factor out a negative y from the second two. So I have 4 times x minus y. You can factor out a common binomial of a plus b from the two terms in the denominator, and you're left with x minus y. And then you see there's a nice cancellation, 4 over a plus b. Okay. Next. Yeah, so scientists classify skulls based off the L value, which is the skull's length, and then the W value, which is the skull's width. Seems like one of the professors at our college at Tri-C West got a big grant to buy all kinds of skulls or something. She has a bunch of skulls. I don't remember what her name is or anything. It's probably like I can't even imagine what class she would teach, like anthropology or something, I don't know. But anyways, there's a professor running around at Tri-C West with a bunch of skulls. And something like this would be useful to her. Right, what we want to do is take this formula, this nasty formula, and make it into something a little easier to deal with. Okay? So you can see in the question there, express the calculation as a single rational expression. So we want to take this big, ugly thing and turn it into something that's simpler to work with. So it already has a common denominator, so we got L. Let's subtract the numerators over the common denominator. So what does this formula do? This formula gives you a way of putting a number on a type of skull. And the second part of the question is kind of interpretation of that number. So if your number is really big, it means you have a really sort of round skull. If the number is really, really small, then it means you have like a really long skull. Anyways, here we go. L plus 36W minus L plus 62W over L. And the numerator, the L's are canceling out. And then we have 62 plus 36 is 98 W's over L. So there's our formula. I already inputted that answer. Okay, part B, if the value of the rational expression in part A is less than 75, the skull is classified as long. A medium skull has a value between 75 and 80, and a round skull has a value over 80. Use your rational expression from part A to classify a skull that has a W value of 6 and then an L value of 8. Right, 6 inches wide, 8 inches long. So these are inches. Okay, so all I have to do is plug the 6 and the 8 into my new formula that I found. So 98 times 6 all over L, which is 8. Okay. I can simplify this a little. So that would be 3. This would be 2. And then 98 over 2 would be like 49. So it's going to turn into 49 times 3. What does it not seem right? 6. And then, okay, whatever. 7, 2, 12, 147. Okay. So my value is over 80. So yeah, that would be long, according to them. So, oh, it's round if it's over 80. So I must have made a mistake somewhere. Oh, this should be a 4 right here. That's what I get for not using the calculator. So 49 times 3 is 7, 2, 147, and then divide that by 4. Sorry, guys. 3, 12, 27, so 30 something. Right? 36 point something. So 36 is way less than 75. Let me do that again. God. So 98 times W, which is 6, all over 8. Let me just put it into the calculator. So I don't feel like doing any arithmetic today. 588, and then divided by 8 should be 73. Oh, that's way off. 73.5. Okay, so just pretend like none of that ever happened. And let's interpret our result, right? So if it says that it's less, if your value is less than 75, the skull is classified as long. So they give you options. You put long in there. Okay. Next, find the perimeter of the rectangle. So remember, perimeter is 2 times length plus 2 times width. So in this case, we would have 2 times 9 all over x plus 5 plus 2 times 3x plus 6 over x plus 5. Okay, we can rewrite these as 2 over 1 times 9 over x plus 5. So 2 times 9 would be 18. 1 times x plus 5 is x plus 5. Plus 2 times 3x plus 6 all over x plus 5. I need to distribute that 2. And I'll do that when I combine the numerator. So 18 plus 2 times 3x plus 6 over x plus 5. Distributing the 2, we'll have 18 plus 6x plus 12 over x plus 5. That'll be 6x plus 30 over x plus 5. And then we could simplify, right? Factor out 6, you get x plus 5 over x plus 5. And those will divide out, just leaving you with the answer of 6. Okay, so 6 is the answer. Okay, one of these big ugly ones. So order of operations are important. 5x minus 1 all over x squared plus 4x minus 12 minus 4x minus 7 all over x squared plus 4x minus 12 divided by x plus 6 over x squared minus 4. Okay, parentheses first from PEMDAS. So I subtract the numerators over the common denominator. Remember, you're going to have to distribute the negative. And then, whoops, I'll carry it with my parentheses. and divided by x plus 6 all over x squared minus 4. Okay, so what do we have? 5x minus 1 minus 4x plus 7 over x squared plus 4x minus 12. The parentheses are no longer necessary. Divided by x plus 6 x squared minus 4. Let's simplify the numerator of that first fraction. So 5x minus 4x is x. 7 minus 1 is 6. Okay. Division is the same as multiplying by a reciprocal. And then we're going to factor this thing, okay, and cancel out like terms. So we have x plus 6 times x squared minus 4 is x plus 2 times x minus 2. And then downstairs, we have a plus minus scenario. 6 and 2, the bigger number positive. And then x plus 6, I believe. So these guys are gone. These guys are gone. And you're just going to have x plus 2 over x plus 6, hopefully. Let's go see, make sure I didn't make any mistakes. Yep, I'm right. Okay. Let's see. Got a couple more here. Oh, these are kind of weird. So 5 over x minus 9 plus blank over 9 minus x equals 12 over x minus 9. A couple ways you can do this. First off, maybe you want to get those denominators the same on this left side. So you got 5 over x minus 9 minus, do we even want to bother? No, let's just keep it like it is. Let's see. Okay, so what I'm going to do is kind of solve for the blank in the box. I'm going to subtract this 5 over x minus 9 from both sides. Okay, so I have blank over 9 minus x equals 12 over x minus 9 minus 5 over x minus 9. Okay. So I have blank all over 9 minus x equals 12 minus 5, which is 7 over the common denominator of x minus 9. Okay. In order to get the denominator the same on both sides of this, you can just multiply the right side top and bottom by -1. So I have blank all over 9 minus x equals -7 all over, so -1 times x minus 9 will be -x plus 9, but then that's just the same as 9 minus x, right? So you have blank all over 9 minus x equals -7 all over 9 minus x, and the punchline is, the answer is -7, right? Another one of these. So we have 2x over x minus 6 plus blank over 6 minus x equals, sorry about my writing, 6x plus 5 over x minus 6. I'm going to subtract that again. So subtract that 2x over x minus 6 on both sides. I have blank all over 6 minus x equals 6x plus 5 minus 2x. Let's just cut to the chase, right? It's 4x plus 5 over x minus 6. But then you need the denominators on both sides the same, right? So I need to multiply top and bottom of this thing by -1. So blank all over 6 minus x equals -4x minus 5, because you have to distribute. All over, and multiplying the denominator by the -1 will just turn it into -x plus 6, which is the same as 6 minus x, right? So then your answer is this -4x minus 5. Okay, those last two questions, I would never put those on the test. I think they're silly. Anyways, that will complete the section. Thank you for watching, and we'll see you next time.